Hello everyone, how is December treating you? Every year, I'm so confused why we as a species play Christmas music everywhere, all the time, for nearly a whole month. It's really just a lot, and I like Christmas as a holiday. I apologize for that outburst, but sometimes you just don't want to listen to how all Mariah Carey wants for Christmas is you. Sometimes you just want to hear about a little pond frog that likes to eat hornets. And I hope, for you, that time is now. Welcome back to Sketchbook Biology. Hornets are 22 species of wasps belonging to the genus Vespa. And wasps are a fairly demonized section of the order Hymenoptera. This group also contains insects like bees, the ants, the sawflies, so it's not all bad. But if you've grown up in an area that has wasps, especially the ones that build their nests underground, you might have some less than fond memories of accidentally stepping on one such nest. See, the thing is, it's never fun getting stung. It's even less fun when the pointy end is attached to a wasp. A sting from a wasp is notoriously painful and involves venom that can contain amines, peptides, enzymes that can cause direct activation of pain receptors, inflammation, massive release of histamines, disruption of cell membranes, and even tissue damage. If an angry wasp stings you, you are also very likely to get stung many more times, because unlike bees, wasp stings are not single-use needles. They're not barbed, they're smooth, so they don't break off with one sting. So they'll keep at it, pumping in another dose of venom each time. Hornet stings are worse because they're larger than other wasps, so more venom per sting. Now, all of this sounds like a nightmare, and it is, but for humans, wasp stings are usually non-life-threatening. In most people, the venom from a sting gets broken down over a few days and the body starts fixing the damaged tissues. Where it is life-threatening is when someone suffers a severe allergic reaction to the venom, in which case that someone should definitely involve a hospital. But hold up, let's step back a little bit. Wasps, even hornets, are not out to get you, even if it really might seem that way. But the fact is, wasps are generally a lot less aggressive than people make them out to be, and we usually only pay attention to them when we get stung. But wasps only sting humans because they feel threatened, and or because we got way too close to their nest or source of food. Stinging is just their main form of defense, and the venom causes enough pain to make big animals like humans back off. They're just animals that need to be given their space to do their thing, and professionally removed when they try to nest somewhere too close to us. They're usually pretty chill. But given their behavior and reputation, one would think that animals much smaller than humans would stay well away from wasps. But one would be wrong. Nature is so fascinating because you could be the most dangerous thing it had ever conceived, but there's always something else adapting in the background just to eat you. Even the Asian giant hornet, affectionately nicknamed the murder hornet, the biggest wasp, which was accidentally introduced to North America in 2019, I think, found that there were birds and some spiders that would love having them over as a meal. And more recently in Japan, adult hornets have been showing up inside the stomachs of pond frogs. So we humans, and I suppose the hornets as well, were naturally puzzled at how these animals are avoiding or tolerating the venomous stings. And that is exactly what Dr. Shinji Sugiura, a researcher at the Kobe University in Japan, set out to investigate. In preparation for his experiment, Dr. Sugiura collected 15 specimens of Asian giant hornet, Japanese yellow hornet, and yellow-vented hornet workers. These 3 hornets are found across Asia, and all 3 species are eusocial, meaning they live in colonies with a queen and workers. In Japan, queens start nests alone, lay eggs, hunt prey, and raise the first batch of workers. Once the first workers emerge, they take over the hunting, the nest building, and caring for their siblings. All very cool. The researcher also collected 45 specimens of pond frogs from areas around paddy fields and, well, ponds. These frogs are generalist predators and usually don't attack insect colonies directly. Since hornets, bees, and ants have evolved stings mainly to protect their larvae and nests, pond frogs attack individual workers opportunistically, most likely to face less opposition. Once all the specimens were housed, the hornets in their individual cages slurping up some insect jelly, and the frogs also in their own enclosures feasting on mealworms and cockroaches, our researcher was ready to start his behavioral experiment. The main goal here was to simply see how pond frogs react to hornets. Do they avoid them, or can they tolerate the stings and still eat them? Inside his lab, Dr. Sugiura made sure each hornet was fully capable of stinging by first placing it in a small transparent plastic bag and using forceps to gently press both sides of the hornet's thorax. Almost all hornets responded by repeatedly extending and retracting their stingers. They were good to go. Next, a pond frog was placed alone in a plastic cage. Once the frog had settled, a single hornet was carefully transferred from the bag to the frog's cage using forceps. Then 2 cameras were used to capture the proceedings of the biologically relevant interaction. And because Dr. Sugiura has graciously uploaded a trial of his experiment to the internet, we get to see this beautiful hungry frog absolutely chomp down on some hornet booty without an ounce of hesitation. Love that for him, or her. The researcher repeated this process for each specimen of hornet and frog. Each frog was used only once, and I suppose each hornet was also used only once. Frog and hornet body sizes were also measured to understand how size might influence the likelihood of a successful predation event. A frog was considered to attack when it opened its mouth and its tongue touched the hornet. If the frog successfully swallowed the hornet without spitting it out, this was counted as a successful predation event. For an extra bit of confirmation, frog poo-poo was also checked to see if the hornet had been fully digested. And when all the data was recorded, the researcher used a generalized linear model with a binomial distribution to understand the likelihood of a frog successfully eating the hornet based on the hornet species, the hornet size, and the frog size. That's it. That's all the statistics. And now, let's get to the results. During the experiments, many hornets had tried to sting the frogs in the face, the eyes, tongue, palate, or throat. But the frogs still swallowed them. None of the frogs spat out the hornets after swallowing, and all excreted the undigested parts of the hornets in their feces 2 to 4 days later. Only a small number of frogs stopped attacking or spat out the hornets after being stung. And importantly, no frogs were harmed or killed by the stings. Data analysis showed that larger frogs were more successful at eating hornets. Frog body mass was positively linked to predation success, meaning bigger frogs can tolerate stings better than smaller ones. So, even though hornet stings can be very dangerous to small vertebrates, These frogs not only survived repeated stings from all 3 hornet species, but also successfully ate the hornets, meaning that they can likely tolerate both pain and toxicity of hornet venom. Dr. Sugiura believes this fits in with the idea that pain and lethality aren't always linked. Some stings hurt a lot but aren't deadly, while others can be lethal without causing too much pain. Pond frogs appear to have some kind of extra cool tolerance to both. They also have other bodily features that likely help them deal with the hornets. Their big, tough mouths and stomachs can likely handle spiny, stinging, or toxic prey. Their sticky saliva may also protect the mouth and help swallow the prey quickly. They might also have some physiological mechanisms that detoxify the venom or block pain signals. But all of that will have to wait for other brilliant scientists to discover. And that is where we leave our hungry little pond frogs and their extra spicy snacks. A special thank you to Dr. Shinji Sugiura and anyone else that was brave enough to handle angry hornets and create this beautiful piece of science. And as always, thank you, a whole bunch. You've been lovely. If today is your birthday, I wish you the very best. And if you're not feeling as feisty as a frog enclosed in a small space with a hornet, well, I hope you do find yourself in an adequately large room with your favorite meal. But if you're just out there, counting your lucky stars at not living anywhere near a hornet, please like and subscribe. I'll see you guys again soon. Peace and happy holidays!